So we have 30 minutes right now to go through a few speakers, I think beginning with Pete, and we're going to hear from a couple of our international collaborators, followed by program managers. And I will just let them pass it off to each other, trying to keep it to, 7 or 8 minutes or so. Each talk should give us about 30 minutes. So Pete, can you share your screen now or just begin your?
Yeah, I think I can. Okay, can you see that slide?
Yes, looks good.
Okay, great. So yeah, thanks Todd, and thanks to the organisers for the opportunity to speak today. So this presentation is an overview of float deployment activities out of Australia and some of our science outputs so far. The Australian BGC Argo team is me and Tom Trial and Christina Schallenberg, with strategic advice from Philip and David, and we're funded by Australia's Integrated Marine Observing System. And we work closely with the core Argo team that's been in existence for a while. And our floats have been co-funded, many of them so far, by the Australian Antarctic Program Partnership and the Australian Research Council Special Gateway Antarctic Initiative, as well as capital funding from CSIRO. So this map with chlorophyll in the background shows our deployments so far. So prior to the start of our IMOS-funded BGC Argo program, CSIRO and UTAS deployed about 30 floats in the Indian Ocean and the Southern Ocean with varying sensor configurations. And starting in October 2019, we deployed 2 floats in the East Australian Current that was sponsored by SOCOM. And then from December last year onwards, we've been a bit more busy deploying 2 floats south of Tasmania on a voyage led by Philip Boyd. And these 2 floats had underwater vision profilers on them, which are basically cameras for looking at larger particles and zooplankton. Then 3 floats with all 6 parameters north of Prids Bay earlier this year. Those floats are now under the ice. 2 floats in the southern part of the East Australian Current in May this year, and most recently one in the Coral Sea. Next is one in the eastern Indian Ocean, and then early next year there's a voyage to the Cape Darnley area northwest of Prids Bay, where we'll deploy at least 2 floats, and we're trying to work with partners to deploy more. So our floats have been about half and half manufactured by Teledyne Webb and NKE, and almost all of them except these 2 in 2019 have the full 6 sensor suite of parameters. And we continue to be very interested in working with international partners to use our presence in the area to try to get floats into the Southern Ocean and other areas near Australia. And that's the gist of this slide. So this shows potential deployment opportunities coming up in the next year or so. Some that we haven't allocated floats to, and some that could accept more. All of these voyages are on the RV Investigator, but Australia has a new icebreaker coming online in about 2023-24, and that could present opportunities as well. And then over the next year, we'll be working on refunding of our BGC Argo facility, as well as the core and deep Argo groups in Australia. So later this year, Investigator will be transiting the Great Australian Bight, then early next year going all the way down to Cape Darnley, as I said before, then to New Zealand, and then south of Tasmania to about 55 south. And it would be great if we could partner with others to use these voyages to contribute to strategic gap filling in the Southern Ocean region. Okay, so I just wanted to close by showing a few science highlights so far, and I'll be quick, so please feel free to get in touch for any further information or a PDF of these papers. First, we have a recent paper by UTAS who quantified the biological signature of Southern Ocean cyclonic and anticyclonic eddies. And I think the surprising result from this work is that the BGC Argo data don't reflect the simple view that we might have from satellites that cyclones are upwelling and high productivity and anticyclones are the opposite. Zhao Yang found positive anomalies of chlorophyll and backscatter in both types of eddies, depending on the time of year. And I think this highlights how much we have to understand still about Southern Ocean eddies. Next, we have a paper that I think is hopefully soon accepted, looking at the response of the South Pacific and the Southern Ocean to the Australian bushfires of 2019-20. And we observed from satellites a large bloom in the South Pacific, and the BGC Argo analysis for this work was spearheaded by UTAS PhD student Jake Weiss. And we saw very strong positive anomalies in chlorophyll and backscatter related to ion fertilization of this area by aerosols from those fires. Philip Boyd and Joanne Lord and I are collaborating with Leo Lacour, who's a Marie Curie Fellow. And Leo is analysing data from some of our earlier BGC Argo deployments, and he's partitioning the particle export into the different types of particle export, these particle injection pumps that Philip has published on before, with a view to looking at their seasonal variability. And Leo gave a talk on this at the SOCOM workshop. Last year, we published similar work led by Seb Moreau, and Seb used BGC Argo to partition the grazing and export of marginal ice zone blooms and looked at a series of 9 floats in different regions around Antarctica. And as Christina showed yesterday, she's looking into fluorescence on BGC Argo floats as an indicator for ion limitation in Southern Ocean phytoplankton. In the future, we'll continue to focus on the Southern Ocean and Antarctica, and we're also pursuing research on East Australian current eddies with a proposal for a ship time just submitted, and also other grants to look at the impact of marine heat waves on phytoplankton. Okay, thank you. With that, I'd like to close and I'd be happy to take any questions.
Thanks, Pete.
Quick comment on UVPs, Pete? Any update?
You want me to say something about the data? So Leo Lacour has been working on those data. Yeah, I don't have too much to say about them so far. They did some sort of calibration or cross-checking by putting UVPs on the CTD on that voyage as well to try to compare the profile data from CTDs and water samples with what was coming from the float. So I think some of the issues around those instruments are that it's sort of a condensed version of the data that's sent back, and so you do need some ground truthing perhaps. So, but Leo's been working on those data quite hard, and I haven't seen a lot of results, but that's been his focus from that voyage. We're actually one more of our floats that we'll be deploying early next year has the UVP on it as well. And so that'll be going quite close to Antarctica.
Okay, well, we should, I think, move on to the next talk. I think, is Katja out there?
Yes, I don't seem to be able to share my screen. It's grayed out. Do you? Ah, there we go. All right, so I want to give a brief update on sort of Canadian BGC Argo activities, and just to give you a little bit of the history. So Canada has been quite a committed contributor to the core Argo program since the early 2000s. And so there was quite a bit of sort of interest and enthusiasm for getting into BGC Argo as well. We had a workshop in 2017 in Halifax, sort of for planning, getting the community organized. And you can sort of see in this picture there the usual suspects from the Canadian Argo community. Ken was there too. Maybe you can pick him out. And we sort of, out of that workshop, wrote a vision and white paper sort of to lay out recommendations for Canadian engagement in the program. We have a website too that you can check out. So I'm going to first give a sort of very high level quick rundown of activities. And I'm going into a bit more detail on the latest. So Laval University, Marcel Babin, in collaboration with Hervé Claustre and so his French colleagues, have been quite active early on in terms of BGC Argo deployments and been pushing sort of the technology to go under ice. So there have been a number of floats deployed in Baffin Bay, which is ice covered in the winter. And so they have several seasons of under ice data. Then on the West Coast, University of Victoria has been adding oxygen sensors to a number of the core Argo floats that are put in the water by DFO, the sort of the government Department of Fisheries and Oceans in Canada. In the Pacific, then Ocean Networks Canada is a bit of a new player in the Canadian Argo community. They're basically responsible for the cabled observatories, but are interested in getting into Argo and BGC Argo as well. And they are planning to deploy 6 4-parameter floats in the Pacific. Then on the technology side, there is a project that was funded to support RBR, which is a sensor company, a Canadian sensor company, to work on, so they build CTDs. The CTDs are on some of the floats. You might be familiar with them in that context, but they're now working in collaboration with us at DAL and DFO to also develop prototype floats with sensors for oxygen and biooptics. So they have had oxygen sensors for quite a while, and now working on also producing biooptical sensors. So that's ongoing. And then lastly, there's been a relatively big investment announced in BGC Argo floats recently. So that's a project that's led by myself in collaboration with a number of people across Canadian universities, including Memorial University. Utapaso is the co-lead of that project, where we're in the finalizing stages of securing funding for 42 BGC floats targeted on the North Atlantic. I'm just going to say a few more words about that. So we have planned 32 floats with the 6 sensor suite for the standard BGC Argo mission, and then set aside 10 floats with most likely a lighter sensor load for process-oriented sampling. So thinking here of floats to be deployed and recovered in connection with process cruises, sampling at a higher temporal resolution. So those type of applications. The grant also includes money for lab renovation and high performance computing infrastructure, because we do want to be able to sort of take those data all the way to the generation of products that are useful for stakeholders. And so science questions we're interested in, no surprises here. It's very much the same science questions many of you are thinking about too. But in this region, in particular, the Labrador Sea, right, we're quite interested in the sensitivity of carbon sequestration and ventilation to changes. Of course, the rate of change in productivity and oxygen loss and acidification, and also assessing ocean and climate models in this region. It's a region that's notoriously challenging to models to get correct. It's also a really important region, so it's the global overturning and ventilation and carbon sequestration. So, you know, that's why we're sort of interested in those questions in particular. We're also focusing a bit on infrastructure development. So partly this is lingo to make the funding agency happy. They fund infrastructure only. So we're trying to develop approaches for rate measurements, so NCP, net community production, net community respiration, export, following these approaches that we've heard about in the last few days. We also want to develop algorithms for combining ocean color with the Argo observations for 3D products, and a data assimilative prediction system for the region for optimal hindcasts or reanalyses, nowcasts and products. And that's sort of something I just want to spend a little bit more, a few more words on the next slide. Before I go there, here's this graph sort of shows the projected increase in profiles, oxygen and nitrate in the region going forward. So the left panels here show what's been available historically from 1965 to 2019 in terms of profiles from bottle, CTD, and Argo measurements, and the right slim panels show you what we're sort of projecting going forward, assuming these previous sample collections go at the same rate, and the light blue is what this project hopefully will add. So we will get a big improvement in terms of information about the region. So last slide, just one quick example. I said we want to develop a data assimilative capability for this region. We have something like that set up in the Gulf of Mexico, actually. So there are 2 papers here, one still in discussion, talking about that, where we have an assimilative model set up. So the first study there at the top looked at optimizing the biogeochemical model using the limited BGC Argo data that's available in that region, and sort of showed how even limited a few, relatively small number of profiles can lead to a big improvement in this in the representation of subsurface fields. So we found that, for example, carbon export was much improved by using the profile information from the biooptics. And then the second paper there shows an assimilative model where we currently assimilating satellite observations and core Argo profiles, not BGC profiles, because there aren't enough for that type of exercise. But even the assimilation of the data in a model that was properly tuned by just a few BGC Argo profiles is already giving us a big improvement. Yeah, and so the graph there on the bottom shows the basically the shape of the loop current and loop current eddies in the region from satellite, which is the black line, from a free model run, which is the blue line. You can see that it's not quite matching what the satellite sees. It can't really if we don't put in the information in some form, right? Because it's a stochastic part of the variability, and the deterministic model has no way of knowing where exactly in which locations the eddies should be at which point in time. And by assimilating, we sort of correct for that, right? We can force the loop current to be in the right location, the eddies to be in the right location. And here on the right now, I'm going to show the impact on the subsurface chlorophyll distribution. So the top panel is basically what the float observed. So you see the chlorophyll evolution through time. The red line follows the deep chlorophyll maximum. The black line shows the sea surface elevation. And yeah, there are 5 floats that are included here in this graph. So that's why there are 5 panels. The row below, the panels below, show the simulated chlorophyll from the free run. So this is a model that's not constrained by observations. You can see that sort of on average, the vertical structure looks right. But so in particular, the middle panel shows you that the model doesn't have the eddy structure at the right time in the right place. And that's why the subsurface chlorophyll distribution doesn't agree well. Now the panel that just popped up below that shows the assimilative run, where it's much improved. And so an important bit of information is that it's only improved because we previously tuned the model to properly represent the subsurface structure using the limited BGC Argo observations that we had available. And that's because, of course, the bottom panel shows the subsurface nitrate distribution, because the information that's contained in the observations about the density structure in the subsurface, of course, then also means that we have information about what the nutricline is doing. And more details, of course, in these 2 publications there. And maybe I'll stop there and turn it back over to you, Todd.
Thanks, Katya. Really interesting. Are there any, maybe a quick question from the audience? I'm not sure if there's anything in the chat. I see Emily says, are these in the DAX? That really is a reminder of the importance. I mean, when I think about both what Pete and Katya said, that the importance of coordinating international float deployments and having some central databases where we can view all floats from the different programs and planning for future deployments.
Right. So these were deployed by the Bureau of Offshore Energy Management, I think is what the acronym stands for, BOEM. You can see it there at the top panel. So this is not data that we collected, but we got our hands on it. It's not in the GDAC, but they've been pretty generous in sharing it with anybody who asked.
Mm-hmm.
But absolutely agree with your point, Todd. Yeah.
Well, I think to keep on track, and we can come back to this. We have some time for discussion later if there are more questions. But let's go ahead and move on to Hetty, who I think has a few words. Hetty's the chemical oceanography program manager at NSF.
Yeah, hi everybody. Thought I had changed my background. So let me see if I can do that again. And if it doesn't want to work, I'll stick with this virtual one. So as Todd said, my name's Hetty Edmonds. With the U.S. National Science Foundation. I'm a program officer with chemical oceanography. So my remarks here are a bit different than everybody else's. I didn't prepare any slides because they just would have been filled with text. So that didn't seem worth doing. I'm talking on behalf of a lot of my colleagues at NSF. Here because I've played a role on the science side of the house in both the review and now management of the GO-BGC Infrastructure Award. As Ken mentioned, the Infrastructure Award is just that, together with a subsequent award that covers the operation and maintenance of the floats. What NSF has committed to date is the acquisition and construction, the deployment, and operation of these 500 floats over the next several years. And that means that, say, unlike with the SOCOM program, no specific science has yet been funded. And now that you've all had these great tutorials this afternoon and seen all these really super interesting talks throughout the week on all the great things you can do with profiling float data, it's time to put your best ideas forward and get out there and use this resource as it continues to develop, recognizing there's already a lot of floats out there, as we've seen. I know a lot of the participants in the meeting are from outside the US. And so for you, I want to reiterate that all of the GO-BGC float data will be freely available. There are no national or other proprietary barriers to you accessing and utilizing those data. For NSF researchers or would-be NSF researchers, my basic message today is that the ocean sciences programs at NSF are open to proposals that utilize profiling float data to address interesting questions. The other point I'd like to make is that the funding of the GO-BGC array doesn't affect our ability or willingness to continue to support proposals that include targeted deployments of additional floats, as we've been doing for the last several years. If you have a specific science problem that you want to approach with a small number of floats in a given area, perhaps you want a specific configurable profiling interval or a specific set of sensors, we're still very much open to those. It's not like it's just, these 500 floats are the thing and that's it. We're also open to continued technology development proposals as well. So in summary, I think the funding of the array and all the growing international contributions open a lot of new doors for some really exciting science. And all the ones that have been open so far remain open. So keep the proposals coming. If anybody has an immediate question, that's great, or I can turn over to Emily Smith from NOAA.
Okay, I sang Baba Black Sheep in my head. Isn't that what you're supposed to do? So I'm going to share my screen. If I can do this correctly. It's always a challenge, right? Excellent. Okay. So following on to NSF, want to talk a little bit about NOAA and what we've done with BGC to date and where we're planning to go in conjunction with the GO-BGC project. So for those who don't know, over the last 4 years, NOAA has invested $11 million in BGC Argo, including support of the SOCOM project, which is a multi-agency effort. And some of the things we've did, you heard yesterday from several folks talking about the pilot arrays that are being initiated in different US regions. Also looking at sensor data quality and improving sensors, you know, the improved pH sensor, oxygen sensor, were all partially funded by NOAA. The biggest investment I would have to say that NOAA has made so far is people. At our two labs, in our Miami-based lab and our Seattle-based lab, you can see the plethora of folks that we have hired over the last 2 years. And really starting to bring out our expertise and also to build physical lab space in order to incorporate these floats. We have several academic partners through our cooperative institutes, and you've heard from some of those folks like Sarah Perkey and Rue Nicholson. We're also building up the US DAC so that all this data will continue to be free and available. We're partnering with Embari to learn their real-time QC processes, and you can see the 3 bottom folks to the right are all dedicated to the DAC and processing BGC Argo data in real time and getting it out. Another really interesting project, there was a postdoc that was hired at our geophysical fluid dynamic laboratory in New Jersey, and she is looking at the physical and biogeochemical variability in the California current, and also comparing that to regional and global models to see if that variability is accurately represented. So that's another really strong suit of NOAA is our modeling team that we have. For our long-term vision, you know, BGC Argo started as a collaboration with NSF as the lead and NOAA and NASA also partnering. We collaborate, you know, you've heard from Lynn Talley about how we use GoShip to help deploy these floats. And I do not see that changing. I mean, it's going to be a collaboration going forward. And I think that's a good thing, right? We're pulling the strengths from the best of the best. If any of you dug into the FY22 budget, the president's budget, it's very encouraging for NOAA. It's very encouraging for Argo, specifically in the program I sit. So of course, we don't know if that will be finalized through Congress, but it's exciting to see an uptick in supporting ocean observing. And if those things do come into fruition, just like Hetty just announced, NOAA will be doing a competitive research opportunities at FY23 if you know budgets allow. So that's why I have my fingers crossed. Because right, it's one thing to get the data out there and make sure the data is accurate and high quality, but it's another thing to then use that data, right, and have really good applications for many different sectors of society. We also really would like to expand some of our ongoing education efforts. I enjoyed George's talk this morning about the Adopt a Float, and I know that Emily Osborne at our Miami lab is interested in doing something similar or just partnering to build on that effort with the NOAA floats. We also have a program called CREAD, a super long acronym, but what it is it's a partnership with some teachers in New Zealand who actually go out to the Pacific Islands and train teachers to then use Argo data, climate change lesson plans, sea level lesson plans in their classrooms so that the students get that real life interaction with ocean observing and how that affects their everyday life. And so it's a great program, and we would like to expand it to include BGC Argo as well. And you've heard all the success of Argo, right? You know, through this last few days, you've heard about technology, data quality, and you know, having that open data access was the core, one of the core fundamentals of how the Argo system was started, and that every country that wanted to be part of Argo agreed to that, right? And that's how we've been so successful. And it's the people. The people in the Argo program are, I'm biased, but they're some of the best people I've ever worked with. And so because of them, Argo is successful. And I know that BGC clearly will continue in that tradition. And I will take any questions if you have them. And if not, can't see my stop sharing.
Emily,
Sure.
Ken here. Are there plans to sustain and expand the California Current and Gulf of Mexico arrays?
Yes. Yes, NOAA will keep those going. Those are definitely in the plans. I think Emily Osborne, correct me if I'm wrong, but I think for the Gulf of Mexico, it's supposed to be about 15 BGC floats, and the California Current is 20-ish. Is that correct?
That is the aspiration. Ken, for next year, we have one float that we've ordered from Seabird.
Thank you.
All right. And it goes to, if I can find my agenda.
Yeah, thanks, Emily. I think that you're the last one.
Fantastic.
That C-READ program is cool. It kind of makes me think about our own need here to expand into the interior of our country. I was excited to see some of the states on Georgia's map, including my home state of Kansas, where they've actually reached it's about as landlocked as it gets.